Hi, good people. Today we're going to be creating an enemy spawner system that creates enemy blueprints in a circular perimeter around the player. Let's not waste any time and just jump right into it. Alright, so let me show you the default project we're working in. We have a player blueprint with a movement component, so I can move around. It changes the sprite flipbooks. And then we have our enemy blueprints here, where they have a sphere collider and a capsule collider. The sphere collider is what you see on the outside. If you enter it, the enemy will turn towards you and kind of move. There's a inner capsule collider, where if the player interacts with that, it'll start a battle. So like if he catches me, it basically kicks the battle off. After the battle's finished, the enemy gets deleted, and then you're back in the world and the player can move. So what we want to do is we want to be able to create a system that can spawn our enemies in a circular fashion around the player, and we want a way to toggle that on and off. So here's how we're going to do it. We're going to head into our player blueprint. You can of course do this in a game manager. Either one's fine. I'm going to go near the begin play because I kind of want this code to kind of kick off right when we start the game, and we want to create a custom event. We'll call this our enemy spawner, and then what we want to do is we want to run this event every so many seconds. The way we can do that is on the begin play. We can pull into a node called set timer by event. And then we can specify to loop, and then we can tell it to run every maybe 2 seconds, but maybe I'll do 0.5 seconds. So it's a little bit quicker for us. And then you simply hook the event pin into the event node here, and we'll just add a reroute node. So this will basically kick off. Now, if you want to be able to control this behavior to turn the timer on and off, you'll want to promote the return value to a variable that we can call our enemy spawn timer. And that way, anytime you want to turn it off, you can just do clear and invalidate timer by handle. And you can, of course, restart it using the same logic as well. All right, so I want our enemy spawner to do a few things. I want it to check the total amount of enemies on the screen, because I don't want to flood the screen with an infinite amount of enemies. I want to be able to control that. So the way we can do that is we can add a variable that we can call our enemy count, and this will be an integer, and we'll initialize it to be 0 because we have 0 enemies, and then we'll use another integer that we'll call max enemies, and we're going to initialize this to be maybe 20, so we can at most have 20 enemies on the screen. And then what we can do is we can say, we can get our hold control, drag the enemy count in, and then we can say, is our enemy count less than our max enemies? And we'll plug this condition in here. So if our enemy count is currently less than our max enemies, then we can continue to spawn enemies. So we want to be able to spawn in a circular like perimeter fashion. So we need to do a few things. We need to figure out the radius of that circle. We also need to calculate the offset of the circle from the player. And then we need to combine all that info into a vector, which is the point at which we're going to spawn the enemies. So we can do this with three, those are kind of three different things. So we'll create them as three different functions. So we'll create a function on the left by clicking this little plus sign here. And this will be a calculate the radius. This one's going to have 2 inputs. So I'm going to click the little plus sign on the input. The first one will be our outer radius, and this is of course going to be a float because we're talking about a radius. And then you probably guess the second one is going to be our inner radius. We also need one output. The output is going to be our final calculated radius. So we'll just call this our final radius. And that's our first function. So I'm going to go ahead and click the plus sign to add our second function, which is the offset. So we'll call it calculate offset. This one has only one input that we can just simply label as radius. And it's going to have actually 2 offsets. The first one is going to be our X offset, and the second one is our Y offset. So when you're dealing with vectors, think of an XY Cartesian graph. You have the left and right is your X axis, and the up and down is your Y axis. So we're gonna have an X and a Y offset, which will be the position where we spawn the player, or the enemy, I should say. All right, so that's the second function. The final function is we're going to take all that information and we're going to figure out, the vector. So we can call this calculate vector. And this will be the final spawn location for the enemy, basically. This one's just going to take in 2 inputs. We'll call this one, we'll reverse it. So we'll call it the offset X and the offset Y. So it's easier to read. And then we only have one output here. This one is going to be our actual spawn point. This one's going to be a vector. So it'll have an X, Y, and Z. All right, so now that we have our 3 functions kind of staged, there's nothing in them, they don't do anything. We can basically kind of draw the skeleton of our code. So we can say we're going to calculate our radius. From our radius, we need to calculate our offset, and then once we figure out our offset, we need to calculate the vector, and then once we have the vector, we can then spawn actor from class. The class I want to spawn is going to be my blueprint enemy, and that looks pretty good so far. So now we just need to hook up the pins. The spawn transform, I'm going to split this so I have access to the vector location, and I'm going to take my spawn point, plug that into there, and then our X and Y offset, I'll plug into our offset X, offset Y. Final radius goes into our radius pin, and we need to figure out our outer and inner radius. These we can just create as our regular variables, so we can maybe call this our I. Well, we'll call this one O radius. This one's going to be a float. And I'm going to make this public, because why not? Doesn't need to be, that's optional. You want to be able to set it in the editor, basically. And then the other one will be our I radius. So our inner and outer radii, basically. So for this one, I think starting off, this is the outer circle. I'm going to try maybe 3,000 units. And then for the inner circle, I'll do 2,000 units. So we have an inside circle, outside circle. We want to be able to spawn our enemy in between the inner and the outer circles. It's basically the principle or the idea behind all this anyways. So you can adjust the circle size, to fit whatever projects you're doing. And then that way it'll control the spawn point. So we'll basically take these variables and we'll plug them in appropriately here. I'm going to drag this down like so. And hook this one up like so. Right, like that. Okay. So that is the code that we have so far. Let's go ahead and work on actually writing out the functions. So the first one we have is our calculate radius. Well, we can take our outer radius and we can square it. Take our inner radius, square that as well. Oops. And then you basically just subtract your outer from your inner squared radius. And then you can take the smaller circle, so in this case our inner radius, and you can add that to the result of the outer and inner squared subtracted from each other. And then if you take the square root of that, you can pass that in to your final radius there. And what that'll do is this is basically just figuring out, it's calculating very small points between whatever your inner and outer radius is. So if we set an inner radius of 10 and outer radius of 15, this is going to calculate something like 11.2 or some nice little number between those 2 points. That way it's a perfect radius every time, and it'll be larger than your small radius, but smaller than your large radius. So it'll be in that sweet in-between spot. So now that we have our final radius, you'll remember after we're done with this, we move into our actual offset, which is our XY. So we can move into that function. And then what we're gonna do is we're gonna get a random float in a range. And this is going to be, we basically need an angle because we're gonna be doing some circular math here. So we're doing between 0 and 360, because 360 degrees in a circle. We're gonna get a random angle, basically. And then you can take that angle and we're going to take the cosine. And I'm not converting to radians because I don't really feel we don't need to. So select the degrees ones so we don't have to worry about converting values. And we want to get the cosine and the sine degrees value for that random angle that we get. And then what happens is if you take the final radius and you multiply that against the cosine, and then I can duplicate that and take the final radius and multiply it against the sine. What this is, if you remember from high school math, is if you take any angle from a triangle and then you multiply that by the cosine, that's going to give you the x value. And if you multiply it against sine, that's going to give you the y value, so the y-axis. So this is just old circular mathematics logic basically here. So this is basically giving our x and our y offset, which is the position or the vector from the player's location to that sweet spot between the inner and outer circle. So it'll be in some random angle, so 0 and 360 degrees, picks some random angle, and it finds basically the x and the y position to give us those coordinates. So we can actually put a mark in between that inner and outer circle position. So hopefully that made sense. But if we go back to our event graph, that is the offset all done. So now we just need to combine all this into a vector, and this one's actually pretty easy. So we can go into our vector function. Didn't really need to be its own function, but just keep it neat. All we're doing is we can just take any component from your player blueprint. I'm just going to use my capsule component because everything lives underneath the capsule. So this will be fine. I can get the world location. I can split that transform. So I have the X, Y, and Z. And then I can add, and then I'm going to duplicate this. So I can take the X and add it to the X offset, take the Y, add it to the Y offset. And then I'm going to split this here. Actually, I don't need to. I can make vector, and then I'll just plug the X and the X, the Y and the Y, the Z into the Z, and then we'll just pass this as a completed vector. And then that's basically kind of the three main functions that's going to get us our spawn points. So if we go back to the event graph here, we can actually, now we don't have anything controlling the enemy count because we're not incrementing, so this will technically spawn infinitely, but just with that, you should see, I probably shouldn't have moved, but enemies are going to start spawning around. You can kind of see them in the map every half a second, and they should kind of spawn in a circle. So what we'll do is we'll start moving back now, and you should notice that it was making a circle. Although I triggered a battle there, so let me wait for that to finish. But yeah, you can kind of see there's like the little perimeter basically. But we want a way to kind of track the enemy counts so we don't spawn too many enemies. So what we can do is we need to find some space. Let's do this. We can make this a little bit wider. So let's drag this down here. Drag this like so. And we'll create another custom event called our enemy counter. We'll have one input. That'll just be a Boolean. It just says increase the count. That way we have a nice easy way to check this. And then I'm just gonna hold B, click on the graph, give myself a branch. And then if it's set to true, I'm gonna get the enemy count. And I'll pull off that and do a increment or plus plus. This will get the current value and increase it by 1. If it's set to false, then I'll get the enemy count and I'll do minus minus or decrement. And then I'll get the current count and subtract 1. And then all we have to do is on the enemy spawner at the end, we just simply call enemy count or enemy counter. So now if we compile and save this, we'll give it a half a second, but there should only be no more than 20 enemies plus the one that was already in the level. And then no more should come, so we'll give it, what would that be? I guess 10 seconds, right? So before it's done. Although it looks like something's not working right, because that seems like it's more. All right, how many we got? 3, 6. Yeah, that definitely looks more than 20. Also, we notice an issue where they're not moving, so we'll need to correct that real quick. Actually, there's a few issues. You notice they're floating as well. So what we can do, let's first figure out what I did wrong. Okay, so we're increasing the enemy count. Enemy count is less than max enemies, which is 20. Oh, I didn't set it to increase, which is funny. So it wasn't increasing the counter. The other thing is on the spawn point. If we look at the spawn point should be 0, but I think with my player blueprint, I have him moved a little bit. Yeah, he's not quite at 0. So what we can do is on the code here, we will break this, and then I'm going to split the structure pin. I'll just pass the X and the Y, and I'll leave the Z transform at 0, so it's at world origin, because I don't feel like fixing the blueprint for the player. But let's go ahead and fix the other thing. Is the way the movement's working is we're using a movement component called the floating pawn movement. If you select the pawn class enemy, you'll notice it has an AI controller where it auto possesses the AI if it's placed in the world. Well, that's the issue. We're not placing it in the world, we're spawning it. So we want to set this to place in the world or spawn. That way, it not only will this enemy track me, but the other enemies will be able to actually be possessed by the AI and have movement capabilities, because we're not using a navigation mesh. It's just basic interpolation between 2 points. So it's very, very basic movement, but it still needs that movement component thing. But all right, so now we give it about 10 seconds. There should be no more enemies. So we can see how we did here. It looks like we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, maybe 20. It's 20, yeah. Plus 21 with the one in the middle. So now that looks like it's working. And now if I go inside one of their little circles, you can see they get aggro. They don't move unless I move. If I leave their sphere, they just kind of go back to their default rotation. And then if they touch me, it starts the battle. Once the battle's finished, basically the actor gets destroyed and the player can move again. So this is perfect. This is exactly what I wanted to build. But all right, everyone, I think we will cut the video here, but I hope you found some informative value that you can take into your own projects. But as always, thanks for watching, consider subscribing, and we'll see you on the next one.